Hi, it's Matt from PilotPracticeExams.com, where you can pass your exams in half the time. I'm going to show you how to use our altitude calculator so you can really rapidly learn pressure, altitude and density altitude. Now, I'm going to put together several videos on this page because I want to break it up so you don't have to watch the whole lot in one video. And that way you can just go to the section you want. So this first video is going to deal with the calculator. The second video is going to deal with density altitude, and I'll put a third video if need be. Now the first video, let's get into it. This is the calculator I've put together here. Now why would you need a calculator when you have to learn how to do this stuff in your head? Because you've got to do 10, 20, 30, 40, 50, 100 of these before it sinks in. And you need a quick way of seeing if you've got your answer right. And you need to throw together different numbers to what the textbooks are throwing at you so that you don't just rote learn the same content, okay? We need you to be able to, have wildly different numbers thrown at you and still get the answer correct. So this first section is just to do with pressure altitude. Now, pressure altitude simply means what is the difference in our aircraft's lift performance, okay? And it affects engine as well, but due to the pressure being different to a standard atmosphere. Now, a standard atmosphere is 1,013 hectopascals. So if the pressure is lower, right, so we've set that to say, let's go roughly 1,000 feet, 997. And we set the pressure to 1013. So it's just like taking off at 997 feet. But watch what happens. If we go into a high pressure system, it's like taking off at 577 feet. In other words, there's more lift available. Now, why? Because when there's higher pressure, it means that the air particles are closer together. It's more dense, and more dense air can produce more lift, okay? Because our lift is dependent on the density of the air. Now, if there's less air density, it's like having less lift. So, in other words, taking off at, say, roughly 1,000 feet, in 995 hectopascals is roughly like about 1,500 feet. So what that effectively means, if you're taking off at an airport with 1,000 feet, it is like taking off at an airport at 1,500 feet just because of the pressure variation. Now you need to be very careful because you can run out of runway or hit trees and things at the end of the runway if you don't get this right. Now the second part of the calculator deals with finding density height. Now, to find density height, you first need to find pressure height. But the way I've built this here is just for visual learners so you can play with it and learn the relationship, okay? This here is the actual calculator that you're going to use as you're doing hundreds of solutions to learn, okay, that you're going to input your data. So if your pressure is 1020, you can input it there. If your altitude is 5,000, you're going to input it there. Okay, now if we go up here and we go 1020 and we go roughly 5,000, I can't go there. So we'll go 4020 and what do we got up there? 1021. You'll notice that the answer 4260, sorry, which is Mount Hotham, the highest place in Australia. Okay, the answers are the same. So this line here is exactly the same as these four cells. Okay. This one allows you to use the slider, visual presentation. This one allows you to use numbers and get exact calculations. Now there's the formula it's using from these two numbers to get pressure altitude. And that's the formula you need to learn to calculate in your head. So you're going to be doing that with numbers like this, and you need to work out this yourself and then cross-check it in here. Okay, the second part of this is you need to work out the variation in temperature compared to a standard temperature for a particular altitude. Now the standard temperature is 15 degrees, so don't change that ever in here. And here's the formula that you're going to use, right? So 15 minus twice the number of thousands of feet. So in this case, and remember it's this, not this, okay? So this here is 5,000 feet. We want to compare the temperature compared to what it should be at 5,000 feet. So if our outside temperature is 20, okay, and we go with 5,000 feet. At 5,000 feet, twice the number of 1,000 feet, so 2 times 5 is 10. So 15 minus 10, the ISO temp is 5. So it just used that formula 15 that minus 2 times that equals that, right? And that's the eyes and temp. In other words, that's the standard temp for 5,000 feet. If we change that, you'll notice the eyes and temp changes. So at 10,000 feet, the eyes and temp, the standard temp would be minus 5. And what we want to do is compare our outside temp to the standard temp. Okay, so let's go back with 5,000. The standard temp is 5. If we're on a 20-degree day, then all you need to do is you input your temperature there that you're working with, and then over here you need to manually input. Sorry, the calculator doesn't do this for you because it can't deal with the difference like an Excel spreadsheet can. Okay, so what you do is you just chuck in the difference between that number and that number, and you need to be careful that you put it in as a positive or a negative. So in this case, the difference is plus 15, so we just put in 15. Okay, now that then gives us, that is what we call our eyes and temp deviation. The eyes and temp deviation is the difference between our standard temperature for that altitude and what our current outside air temperature is at that altitude, and that's called the eyes of deviation. Now once you know the eyes of deviation, you can then go on to step 3. So step 3 is times your eyes of temp deviation, this number here, by 120, and you will get this number here. Okay, now that means because the temperature is 15 degrees warmer, it is having an 1800 foot effect on our altitude for our lift and the performance of our aircraft. Okay, then what we do is we go, right, well, that's how much effect there is due to eyes of temp deviation because of the temperature and therefore the air density. We add that to the effect, which is coming from up here, of pressure, and we end up with our total effect, which we call density altitude. In other words, due to the effect of temperature and air density, and due to the effect of pressure and air density, this is the effect. So instead of taking off with the performance that you normally have at 5,000, if this is the numbers that you put in, it's going to be effectively like taking off at 6,500 feet. And as you can imagine, that is going to dramatically affect your aircraft performance, especially if you've got a heavily loaded aircraft or you're on a marginal length runway. So that's how the calculator works. Thanks for watching. Make sure you watch the other videos. I'm going to have a really good explanation of these diagrams down here. And anyone who struggles with this, which is most people, this next video is really, really going to help. I'm Matt from PilotPracticeExams.com, where you can pass your exams in half the time.